Hi everyone, so we are going to move on to this next section that's going to mainly focus on Earth here. So we are going to continue a little bit with the sun and the moon in class, talking about those seasonal changes and the effects of that tilt with our moon. But continuing on from here, we're going to be talking about these interacting systems, so the really driving relationship here. So our interacting systems are inputs into Earth's interconnected systems, including energy, information, and matter. So feedback loops are going to help regulate these systems. So you might have heard of a feedback loop, possibly in biology. They're very heavily used in anatomy. So we are going to kind of talk about how they can pertain here. So negative feedback loops, the goal of a negative feedback loop is to bring stabilization to the system. So a good example of this, as you can see right here, if your body temperature is too hot or too cold, we're going to try to get back to normal. So if normal's right here, too hot or too cold, we're going to go to our control center, our brain. It's going to tell us to do something to help cool our body, and it's going to bring us all the way back to our normal body temperature here. Same thing if it's too cold. We're going to get signals that tell us that, and we're going to try to fix that to bring it back to a stable environment. A positive feedback loop results in the system moving to one extreme or the other. So that might be a dam is a good example of a positive feedback loop. So when that dam is built, instead of having a flowing river, our extreme here is having that very still lake there now. So that would be maybe an example of a positive feedback loop because it's going to change our system here. So when we're talking about the Earth, we're going to be talking about some of the effects that happen within the Earth, and that's going to be looking at our atmosphere. So if we're talking about our biosphere and our atmosphere, let's define these terms real quick. So our biosphere is the part of the Earth in which living and non-living things interact. So that's going to be really focusing on our ecosystems. And then our atmosphere contains these gases that organisms need. So that would be oxygen for us, carbon dioxide for plants, and it keeps the Earth warm enough to support life. So we're going to start focusing a little bit more on this atmosphere topic right here. So the Earth's atmosphere, the air we breathe, and all the weather that we see is contained in the lowest 1% of the Earth's atmosphere. So we're going to talk about those different layers here. So some properties first. Our composition is 78% nitrogen, 21% oxygen, and 1% of other gases. So some of those other gases can include that carbon dioxide and things like that. So our temperature is going to vary upon location, and we know that when we're going to be talking more about seasons and that direct sunlight and how that relationship occurs between the sun and the Earth. And then our pressure, in general, the air pressure decreases with altitude, and it can be measured by a barometer. So that's a tool of measurement here. So we know that as we go higher from sea level, the air pressure increases, and as we go lower than sea level, so if we go deep into the ocean, that pressure is also going to increase. So right now where we are at a good pressure for us for survival. So let's talk about these layers of the atmosphere and what we're going to find in each of these layers. So the troposphere.
Miss Prendergast, call the office, please.
Our troposphere is that air that is going to be right close to the Earth. If you look at this right here, we have our troposphere down here. And we're going to see that's where we're going to see the movement of air and weather that we see. Our stratosphere is our ozone layer that absorbs and scatters the UV radiation from the sun. So that's our next layer up. Our mesosphere. This is where we're going to see the destruction of maybe some meteorites that are trying to come through our atmosphere, which is going to be really important so we have less collisions on the surface of the Earth rather than what we saw in our video of how there were a lot of collisions on Earth when it first started. So that's our mesosphere. And then we have our thermosphere. And those disturbances produce the aurora borealis. So those light differentiations are really going to show you that in our thermosphere. So temperature in the atmosphere, as we move up, what should happen to the temperature? So there are two different temperature inversions that we kind of saw on the side of that graph. I'll go back to it in 1 second. So where do these temperature changes happen? So temperature increases with altitude in the stratosphere and the thermosphere. So I'm just going to go back to this graph for a second. So you can see that as we go in our stratosphere right here, our temperature is increasing here. And the same thing in our thermosphere. We have an increasing temperature. Unlike in other places, the higher we go, our temperature is going to decrease. And we can see that with our slopes. Okay. So these different layers of the atmosphere, we're going to talk about composition. So our troposphere again, this is where we live, this is where our weather occurs, and this is the densest layer. Our stratosphere is our temperature inversion, so we increase temperature as we move up. So increase temp. This is where our ozone layer is, so this is where we're going to see that UV radiation, remember, and this is where planes fly. Our mesosphere is our coldest layer, and this is where you're going to see shooting stars. Thermosphere, again, we have that temperature increase. So X-ray and gamma rays, and those creation of those northern lights, the aurora borealis, is going to happen there. And then our exosphere, this is the outer space level of our atmosphere. So this is where maybe a satellite would orbit the Earth, and things like that. So our ozone layer is something that we are going to be talking about a lot, especially. So ozone is a type of oxygen, but instead of O2, it's O3. So this occurs naturally, and it greatly reduces the amount of UVA radiation that reaches the surface. So the big problem with our ozone layer right now is that it is weak, and there are holes in our ozone layer that allow these high levels of UV radiation to reach the Earth's surface, which is helping it gets trapped in our atmosphere, and it's helping create those greenhouse gases there, and heating up the Earth itself. So the ozone layer is very essential in protecting these vital signs of life on Earth. So talking a little bit about the heat transfer in the troposphere, remember that is our level of our atmosphere. So different terms here, we're going to talk about radiation. So radiation is the transfer of energy throughout space, such as heat from the sun to the Earth's atmosphere. Conduction, so it's the transfer of heat directly between two objects that are in contact. So the big word for conduction is contact here. So I want you to underline that somewhere. And then another term is convection. So the transfer of heat by movement. Movement of currents, so that's either going to be in a fluid, and that's a liquid or a gas here. So remember these two terms. So it's the transfer of energy through space from the sun to the Earth. Conduction here is going to be between direct contact between two objects. Convection is that transfer of heat by movement within fluids. So if we look here at this diagram, we have our sun with some radiation here bringing it to the Earth. We have conduction, so near the Earth's surface, the air is heated by conduction, that's the direct contact. And then convection is coming off of the water, so the different heats that come off the water. I'm sure you've heard that in the summertime that it's cooler by the ocean. That's because of the convection currents that are coming off of the ocean, because the ocean is a lot cooler than the air. And usually in the wintertime, it's warmer by the water because it had the whole summer for the water to heat up, and our convection currents are blowing that warm air to the coast. So it's a really good idea to look over this graph for that energy transfer in our atmosphere. Okay, so that's where we're going to end for this one. Remember, we have those guided notes, and if you're preferring to take notes in your own notebook, that's fine too. But I will be doing routine notebook checks, so make sure that we are going through all of these. Okay, I'll see you soon.